Imagine floating through space, but there is no sun, no warmth, no light to guide you. There is only darkness and silence. This is the story of one of the loneliest planets in the universe, PSO J318.5-22. A place so isolated, so far from the light of any star, that it stands as one of the most enigmatic celestial bodies ever discovered. It's a rogue planet, a solitary wanderer adrift in the void, far away from any solar system, endlessly drifting through the cold emptiness of space. Unlike most planets, which are gravitationally bound to stars, PSO J318.5-22 is a cosmic orphan, exiled from its parent star and destined to float alone. But how did this lonely planet come to be? What cataclysmic events cast it out into the cosmic wilderness? And why is PSO J318.5-22 considered the ultimate symbol of isolation in the universe? To understand the uniqueness of this planet, we must first explore the phenomenon of rogue planets. Planets that drift untethered through space, far from any star's light. PSO J318.5-22 is a type of planet known as a rogue planet or a free-floating planet. Unlike the planets in our solar system, which orbit the sun and receive light and energy from it, rogue planets drift alone through the dark spaces between the stars. These cosmic wanderers are not bound to any star, making them some of the most isolated objects in the universe. Rogue planets are, in essence, cosmic orphans, planets that have been ejected from their original planetary systems through dramatic gravitational interactions. They are flung out into the galaxy, where they drift in isolation. But how do rogue planets form? Astronomers believe that they are born in much the same way as regular planets, through the accumulation of gas, dust, and debris in a protoplanetary disk around a young star. Over time, this material coalesces to form a planet, just like Earth or Jupiter. However, some planets experience a violent upheaval in their early years. Gravitational interactions with other massive bodies, such as a nearby gas giant or even a passing star, can destabilize their orbits. When this happens, the planet can be ejected from its star system, sent hurtling into the cold, dark expanses of interstellar space. PSO J318.5-22, discovered in 2013, is one of the most famous examples of a rogue planet. This gas giant, around 6 times the mass of Jupiter, is drifting alone through the galaxy, with no star to warm its surface or light its way. But what makes PSO J318.5-22 truly extraordinary is the combination of its size, mass, youth, and extreme isolation. It is a giant, yet it is utterly alone, a cosmic titan that has been severed from its solar system and cast into the abyss. One of the most intriguing aspects of PSO J318.5-22 is its backstory. How did it end up so alone? To answer that question, we must look at the chaotic early stages of a planet's life. When planets are born, they are part of a delicate dance, a gravitational balance between their parent star and the other planets in the system. This balance can easily be disrupted, especially in systems with multiple giant planets or nearby stars. When these gravitational interactions become too strong, they can cause a planet to be ejected from its system, sending it on a lonely journey through the galaxy. In the case of PSO J318.5-22, this ejection likely occurred when the planet was relatively young. Astronomers believe it was part of a star system in the Beta Pictoris moving group, a collection of stars and planets that formed around 12 million years ago. At some point, the gravitational interactions in this system destabilized PSO J318.5-22's orbit, flinging it out into interstellar space. Now, it drifts far from its parent star, cut off from the energy and light that once sustained it. This ejection process is not uncommon in young planetary systems, especially in systems with multiple large planets. Gas giants like Jupiter can have strong gravitational fields that disrupt the orbits of nearby planets. When these interactions reach a tipping point, the smaller planet is ejected, sent spiraling out into the galaxy. Once a planet becomes a rogue, It no longer has a star to orbit, and it drifts endlessly through space, subject only to the weak gravitational forces of the galaxy as a whole. The defining feature of PSO J318.5-22 is its extreme isolation. Most planets, like Earth, exist in a close relationship with their star. They are bathed in its light, warmed by its heat, and powered by the energy it provides. But PSO J318.5-22 has no such relationship. It exists in a realm of perpetual darkness, where the only light comes from distant stars too far away to provide any warmth. Without a star to orbit, PSO J318.5-22 is adrift in the vast interstellar medium, the space between the stars. The interstellar medium is a cold, empty place, with temperatures plunging to just a few degrees above absolute zero. For PSO J318.5-22, the lack of warmth from a star means that its outer layers are likely frozen solid. The planet's surface temperatures could be as low as minus 270 degrees Celsius, making it an incredibly hostile environment. Without the energy from a star, there is no atmosphere to trap heat, no liquid water, and no conditions suitable for life as we know it. However, this extreme cold does not mean that PSO J318.5-22 is entirely without heat. Gas giants like PSO J318.5-22 can retain some of the heat generated during their formation. This internal heat is trapped deep within the planet's atmosphere, slowly radiating out into space. It is this faint internal heat that made it possible for astronomers to detect PSO J318.5-22 in the first place. One of the great mysteries of rogue planets is that they are incredibly difficult to find. Because they do not orbit a star, they do not reflect light like other planets do. This makes them nearly invisible in regular, visible light telescopes. So how did astronomers discover PSO J318.5-22? The answer lies in infrared detection. Even though PSO J318.5-22 does not have a star to light it up, it still emits a faint glow in the infrared spectrum. This is because the planet is relatively young, and it still retains some of the heat from its formation. Infrared telescopes can pick up this faint heat signature, allowing astronomers to detect rogue planets that would otherwise be invisible. In 2013, astronomers using the Pan-STARRS-1 Panoramic Survey Telescope and Rapid Response System in Hawaii spotted PSO J318.5-22's faint infrared glow. The Pan-STARRS telescope scans the sky for objects that move slowly across the sky, such as asteroids, stars, and planets. Because PSO J318.5-22 was emitting a faint infrared glow, the telescope was able to detect its presence, even though it was invisible in regular light. Once astronomers detected the planet, they used its movement across the sky to confirm that it was a free-floating object and not a star or a brown dwarf. Its size, mass, and movement all pointed to one conclusion. PSO J318.5-22 was a rogue planet, drifting alone through the galaxy. At 6 times the mass of Jupiter, PSO J318.5-22 is a massive gas giant, composed primarily of hydrogen and helium, with possibly some heavier elements deep within its core. Gas giants like Jupiter and Saturn are composed of thick layers of gas, with temperatures and pressures increasing as you move deeper into the planet's atmosphere. The deeper you go, the hotter and denser the gas becomes. However, unlike Jupiter, PSO J318.5-22 does not have a star to warm it. This means that the outer layers of the planet are likely extremely cold, frozen solid due to the lack of sunlight. But gas giants like PSO J318.5-22 also retain heat in their deep interiors. This internal heat, left over from the planet's formation, radiates out slowly, driving powerful winds and storms in the planet's atmosphere. The internal heat of gas giants can create intense atmospheric phenomena. On Jupiter, for example, the planet's internal heat drives its massive storms, such as the Great Red Spot, a storm that has been raging for centuries. It's possible that PSO J318.5-22 has similar storms swirling in its atmosphere, driven by the planet's internal heat. However, unlike Jupiter, these storms are unfolding in a realm of complete darkness, far from the influence of any star. PSO J318.5-22 status as a rogue planet makes it one of the loneliest objects in the universe. It drifts through space without the warmth of a star, without the companionship of other planets, and without the familiar cycles of day and night. Its existence is one of perpetual isolation, cut off from the life-sustaining energy that other planets receive from their stars. For astronomers, it represents the ultimate symbol of cosmic loneliness. The distances between stars are vast, and for a planet like this, there is no nearby star to provide warmth or light. It floats through the interstellar medium, a cold, dark expanse that stretches for light years in every direction. The extreme isolation of PSO J318.5-22 raises profound questions about the nature of the universe and the role that rogue planets play in the broader galactic ecosystem. Despite its extreme isolation and cold temperatures, some scientists speculate that rogue planets could potentially support life. On Earth, life thrives in extreme environments, such as near hydrothermal vents on the ocean floor. These vents release heat and chemicals, creating an ecosystem that is cut off from sunlight, yet still teeming with life. Could something similar happen on a rogue planet, like PSO J318.5-22? While PSO J318.5-22 is a gas giant and unlikely to have a solid surface, the possibility of life on other rogue planets remains an exciting area of research. If a rogue planet had enough internal heat, it could potentially maintain subsurface oceans of liquid water beneath thick layers of ice. These oceans could provide a stable environment for microbial life to evolve, even in the absence of sunlight. The discovery of extremophiles on Earth, organisms that thrive in extreme conditions, has expanded our understanding of the potential for life in the universe. If life can exist in the boiling hydrothermal vents or the frozen tundras of Antarctica, it raises the possibility that life could also exist on rogue planets, where the only source of energy comes from the planet's internal heat. This rogue may be one of the loneliest planets we've discovered, but it is far from unique. Astronomers estimate that there could be billions of rogue planets in our galaxy alone. Some even speculate that there could be as many rogue planets as there are stars in the Milky Way, meaning the galaxy is filled with wandering planets, drifting unseen through the dark. These rogue planets could be gas giants like this one, or they could be smaller, rocky planets more like Earth or Mars. Because rogue planets are so difficult to detect, it's possible that we've only scratched the surface in terms of how many are out there. As our technology improves, we may uncover many more rogue planets, each one a solitary traveler on an endless journey through space. This rogue is a true cosmic loner, a planet that has been cast out into the void, severed from its parent star, and left to drift through the galaxy in isolation. Its lack of a star, its extreme isolation, and its cold, dark environment make it one of the loneliest planets in the universe. But despite its loneliness, this rogue is also a symbol of the vastness and mystery of the cosmos. This rogue planet raises profound questions about the nature of planetary formation, the possibility of life in extreme environments, and the role that rogue planets play in the broader galactic ecosystem. As we continue to search the skies, we may find many more planets like this, each one a testament to the loneliness and wonder of the universe. For now, this rogue drifts in silence, a reminder of the incredible distances that separate the stars and the untold mysteries that still await us in the dark spaces between them. The universe is full of wonders waiting to be found. If you're as captivated by the mysteries of the cosmos as we are, subscribe to our channel. Join us as we explore the deepest corners of space and uncover the secrets of rogue planets like PSO J318.5-22. Let's continue the journey together